Welcome back, guys. Here in this lecture, we are going to discuss about chemical properties of carbon compounds. We have covered all concepts, different concepts regarding carbon, and we have seen homologous series, alkane, alkene, alkyne. We have seen functional groups, everything. Now, chemical properties of carbon compounds. What is chemical property? Already we have discussed the difference between physical property and chemical property. Physical property means if you wanna explain or describe about any chemical or element by means of your senses, it is known as physical property. Chemical property means if you want to explain about any element or compound by means of reaction with other elements or compounds. So in this lecture we completely read about reactions and chemical properties. In this section we will be studying carbon compounds, and we'll study about some important carbon compounds. Here, so in this session we will be studying about some of the chemical properties of carbon compounds, since most of the fuels we use are either carbon or its compounds. If you remember your grade 8 combustion and fossil fuel chapter you have got, in that combustion and fossil fuel you might have heard about crude oil. Crude oil, they will go with fractional distillation, and you can get kerosene, white kerosene, petrol, diesel, transformer oil, etc. And all these kerosene, petrol, diesel, all are hydrocarbon compounds. It is not oxygen compounds. Oxygen will not be present in these. These are hydrocarbon compounds. By this what we can say, carbon or its compounds are used as most of the fuels. Next, there are four chemical properties already we have discussed in last lecture. First one is combustion. What is meant by combustion? If any product, element, or compound or material, if it is mixing with oxygen and if it is burning in presence of oxygen or in addition of oxygen or in supply of oxygen, we can call it as combustion. Now, whatever it may be the carbon compound, carbon or carbon compound, you see carbon or carbon compound, if it is combining with oxygen, it gives carbon dioxide. Sometimes water is released, and every time heat and light is produced. You can observe these equations in textbook. When first equation you can observe, when carbon is reacting with oxygen O2, it is producing carbon dioxide and heat and light is produced. Next, CH4. What is CH4? It is methane, right? CH4 means you can draw like this, CH4. When it is combining with oxygen, you see carbon dioxide is produced, water is produced, at the same time heat and light is produced. So if they ask in examination, when methane reacts with oxygen, what products are released, what products are observed, what products we can get? You can write that equation, CH4 dot plus O2 gives rise to CO2 plus H2O plus heat and light. You see this CH3 CH2OH, how to represent that? CH3 CH2OH. So first, what is this part? CH3, C, 1 2 3 H's, 3H. Next, CH2 bond C H and another H, CH2, CH3 CH2 OH bond OH. Now you see, if they give this structure and if they ask you to write name, what we can do? Three parts. First part, first carbon, second carbon, meth, eth, so it is eth. In between carbon only single bond, so an, don't write E. E should be replaced with functional group. What functional group is present? Bond OH. Bond OH means alcohol, so it is OL. So that compound's name is ethanol. Ethanol is also known as alcohol. Ethanol is also known as alcohol. And when alcohol is reacting with oxygen, burning in presence of oxygen, of course we'll get the same product, carbon dioxide, water and heat and light. So that is a concept we have to learn. When carbon or carbon compounds are reacting with oxygen, products are carbon dioxide, water and heat and light. Now we have three activities, 4.3 and 4.4. In 4.3 they told us to take carbon compounds like naphthalene, camphor and alcohol, try to burn those in presence of oxygen and try to observe the flame of that. And after burning these three, naphthalene, camphor and alcohol, you have to go with one observation that which of these will produce black output, black powder called soot. So it will produce, few compounds will produce that black powder called soot, black dust called soot. Here you can observe alcohol will not produce that, but camphor, naphthalene, you can observe it will produce black soot. Why? We'll discuss. Activity 4.4, take Bunsen burner in chemistry laboratory. You can observe there will be a stand with small cylindrical type which is connected to gas cylinder using the rubber tube, and flame you can observe it, and here at the end there will be one knob, you can adjust that knob. So if you are turning that knob, you can adjust the air valve. By adjusting that, you can get two types of flames. First one is blue color, second one is yellow color. When you can find blue color, when you can find yellow color, in the sense, so whenever you are getting blue color flame, that is meant as complete combustion. Complete combustion. Whenever you see yellow flame, indication is incomplete combustion. Complete combustion and incomplete combustion. In case of complete combustion, no soot is observed. In case of yellow color flame, I mean in case of incomplete combustion, soot, I mean black soot is observed. So now from this what we can say? Alcohol. So if you burn this alcohol, I told no soot, no dust particles, no black color products are formed, because alcohol will go with complete combustion and it is very good fuel. That complete combustion and blue color is the indication of good fuel, and yellow color or black soot or incomplete combustion is representation of bad fuel. If you observe few vehicles which is running with petrol or diesel, it will not produce that much smoke, it will not at all produce smoke or black smoke, but few vehicles will produce. Why? Because they will combine, they will mix kerosene in the petrol or kerosene in diesel because they feel that it is cost efficient. So 1 liter of petrol may cost 80, 83, 85 something. Let us make it 85. So 85 rupees that auto drivers or they may not tolerate petrol or diesel. Let us take example of 80 rupees. They may not tolerate 80 rupees per liter. What they will do? They will take 1 liter of mixed one. So diesel will be mixed with kerosene or petrol may be mixed with kerosene. That may cost something around 50 to 60 rupees. So 20 rupees they may save. Because of that, they are mixing, and because of addition of those type of products, it is leading to incomplete combustion and it is becoming bad fuel, and black soot smokes are produced. That is the reason where you can observe black smoke from the vehicle. And this paragraph will give the same information. You can read that paragraph, you can understand it. Then here already we have discussed mixture is going to give clean blue flame. If you go to your kitchen and if you observe your stove, there will be 2, 3, 4 burners according to the construction of the stove. So if you observe the burner and if you turn it on, you can get blue flame, isn't it? Blue flame, completely blue flame, you will get it. So what is the meaning of that blue flame? From where you are getting that blue flame means from the cylinder. Cylinder has LPG, liquefied petroleum gas, is good fuel. How we can say it is good fuel? Because it is producing blue flame. It is not releasing smoke. Can you observe any smoke from the stove? No. And no soot is released, nothing. But sometimes you can observe yellow flame also. Yellow flame also you can observe. Of course, you are using this LPG only, but why you are getting that yellow flame means if you observe that burner, there will be holes, and because of presence of dust particles in these holes, if dust particles are present in that hole, there will be incomplete combustion. Because of that incomplete combustion, you can observe yellow flame. So whenever you are observing yellow flame, you can turn it off. After becoming cool, take that burner and try to clean those holes, and again you insert and you turn it on and lit it. Definitely you will get blue flame. And whenever you are observing yellow flame, if it is completely yellow, if you place any vessel on the stove to boil the milk or to do something, definitely you can observe that black soot is formed under the vessel. So from this context, what we can understand is carbon will combine with oxygen to form carbon dioxide, heat and light produced. And another concept what we have observed, there will be two types of combustions: complete combustion, incomplete combustion. What is the indication of the complete combustion? Flame will be blue in color, no soot is observed released. What is incomplete combustion indication? Flame will be yellow in color and black soot is observed. That's it. So why do substance burn with or without flame? This concept, it is not important for your examination, but if you want to learn, it is present in your textbook, and in this video also it is present. You can take some screenshots and listen. You can pause this and listen. You can refer textbook and you can read it. Formation of coal and petroleum, which already you have got in 8th class. So how coal petroleum is formed? Simple. Fossils, everything will be under the earth crust, will be crushed with a high pressure and temperature. Then coal petroleum is formed. Entire chapter is there in 8. There also you can refer. Second property, second chemical property, oxidation. We know what is meant by oxidation. Oxidation nothing but addition of oxygen. Now you take this equation CH3CH2OH, CH3 CH2 OH. So what is this compound's name? Meth, eth, and all, ethanol. Ethanol. When ethanol is heated in presence of oxidizing agent. Here guys, you have learned regarding oxidizing agent in chapter 1. What is oxidizing agent? Substance or chemical which is used or which is helped to give oxygen, okay, to attach oxygen. Here there are two oxidizing agent, any one you can use. KMNO4. What is KMNO4? Potassium permanganate. KMNO4 is known as potassium permanganate. And here we have K2Cr2O7. K2Cr2O7 is potassium dichromate. Potassium dichromate. Very important, you have to remember that. When potassium permanganate or potassium dichromate is added to ethanol, and if you heat that ethanol, it will convert as CH3COOH, it seems. What is that CH3COOH? We can draw like this: CH3 COOH, COOH. Now what is this called? Here we have double bond O and single bond OH. So first meth, eth, single bond and double bond O and single bond OH, which is nothing but oic acid, ethanoic acid. So ethanol means alcohol. Alcohol can be converted to ethanoic acid. Ethanoic acid means vinegar, right? So it is, this is the example where we can take for oxidation. So oxygens can be added to carbon compound by heating and by giving oxidizing agent. That is the only concept which we can learn here in examination. How they may ask question is, how can you convert alcohol to vinegar, or explain with the equation how ethanol can be converted as ethanoic acid. That's it. So you have to go with only this formula, I mean equation. No need to explain anything in this concept of oxidation. That's it. Addition reaction. So what is that addition reaction means? It is quite simple. You see here we have this one, C double bond C, and here two bonds for carbon represented with R. Here again two bonds for the carbon represented R. So this already we know it is double bond. Double bond means unsaturated. And what is this R? Reactants. So which element is reacting with carbon? Known as reactant. So those all reactants are represented as R. Now you see, this is saturated, sorry, this is unsaturated. Unsaturated we need to convert to saturated. Why we have to convert? So one concept is there, that is hydrogenation of oil. I'll explain you what is that hydrogenation of oil is. Basically we have two types of oils, guys. First one, oil which we'll get from animal fat. Animal fat. and oil which we will get from flowers or plants, etc., or vegetable oil we can call simply. Okay, vegetable oil. Two types of oils we have: animal fat and vegetable oil. Basically, which oil is good for our health? Vegetable oil is good for our health. Animal fat oil is bad for our health. And another thing, for our health, which one is bad, which one is good, in the sense, for our health, yeah. So here we can take two types of oils, uh, uh, animal fat and vegetable. Here I told you animal fat is bad, I mean animal fat oil is bad for our health, vegetable oil is good for our health. But here, while coming to our health, while coming to bonding saturated and unsaturated, basically saturated is good for our health and unsaturated is bad for our health. Now while coming to vegetable oil, vegetable will have unsaturated, animal fat will have saturated. So you see, don't get confused. Of course vegetable oil is good, but it is unsaturated, we cannot eat it. Animal fat oil is bad, but it contains saturated, which is good. So what to do now? We have to go with only vegetable oil, because vegetable oil is good, but vegetable oil is unsaturated. If you take unsaturated, double bonds and triple bonds, in the digestion, it will go with more and more energy to break the bond. Single bonds, it is very easy to break. Double bonds, it is not that much easy to break, isn't it? So more energy should be applied in our digestive system because of that unsaturated. So here we have a concept: unsaturated can be converted to saturated. So how we can add, how we can convert means by adding hydrogen. If you add hydrogen, what will happen, you know? Here we have two bonds, isn't it? These two bonds will become single bond. It will become single. Basically, you see, valency for the carbon, for this carbon, 1, 2, 3, 4. And while coming to this carbon, 1, 2, 3, 4. Now, if it is becoming like this, carbon, single bond carbon, reaction, here reactant, I mean reactant, here this double bond is becoming single bond. But while coming to the valency, again one new valency will create here, new valency will be here, where hydrogen can be added. So that is the concept you have to understand here. You can observe first, we have unsaturated. Unsaturated carbon chain has a double bond. That double bond should be converted to single bond. How means? By addition of hydrogen in presence of nickel catalyst. Now what is meant by catalyst? Catalyst is a chemical or product or element or substance which will increase or decrease the rate of reaction. So if you want to see fast reaction, you can use catalyst. If you want to see slow reaction, you can use catalyst. For example, you are thinking to make palkova. So how we can make palkova? From milk. So we have to take milk, you have to boil it, and you have to keep that milk for 1 to 2 or 2 to 3 days aside, because that milk should be curdled. Milk should be curdled, then only it will be easy for you to make paneer, palkova, etc. But we cannot wait for 2 to 3 days, isn't it? What we can do? Keep milk on stove, I mean in a vessel and on stove, and when milk is boiling, you can add 1 or 2 drops of lemon juice in that. After adding 1 or 2 drops of lemon juice, automatically milk will be curdled. Milk will be curdled. And you see that lemon juice acts as catalyst. Instead of waiting for 2 to 3 days, that reaction is happening within 2 to 3 minutes. That is meant by catalyst. Catalysts are substances that cause a reaction to proceed at different rate without the reaction itself being affected. So here milk taste will not change. I mean, milk will be milk. It will not become very sour because of addition of uh, lemon juice. So what is the catalyst? It causes a reaction to proceed at different rates. So it may fasten the reaction, it may slower the reaction. Both can happen. So here we are taking double bond, I mean unsaturated. Unsaturated can be converted to saturated by addition of hydrogen in presence of nickel catalyst, such that reaction will be fast and double bond will become single bond. And here we can observe 2 hydrogens got extra. And vegetable oil, basically it is good for our health, but it has unsaturated. You can consider this is the original form of vegetable oil. Vegetable oil is unsaturated. We cannot take that unsaturated directly. It is not good for our health. So we are converting the unsaturated to saturated by addition of hydrogen. That is known as hydrogenation of oil. Hydrogenation of oil. So if they ask you what is meant by hydrogenation, they may ask for 1 mark or 2 marks. You can say basically vegetable oil which is unsaturated, we cannot take unsaturated, and saturated oils only we have to take it, but we cannot take that unsaturated directly, so that we need to convert that unsaturated vegetable oil to saturated vegetable oil. How can we convert? Means by hydrogenation of the oil. Hydrogenation of the oil is the process of converting unsaturated to saturated by addition of hydrogen. That is a concept we have to understand from addition. And last we have substitution reaction. Substitute. You are aware of cricket, football games. Consider if a player who is playing football, he got hurt. Then retired hurt they will take, and another player will substitute this player. And in schools also, if one teacher is absent, another teacher will substitute the class. If physics teacher is not there, math teacher. And it is more obvious, if PT teacher is not present, definitely math teacher will take the class. He will substitute all other classes. Math teacher will substitute physics, chemistry, bio, and every other. So like that, substitution you have to understand. Now what is substitution? Here we have one small equation. You see, CH4 plus Cl gives rise to CH3Cl plus HCl. What is that? We cannot understand. Let us try to draw diagram. What they told, CH4 plus Cl, this one, CH4, right? 4 hydrogens are there. CH4 plus Cl. Now chlorine is given to methane. This is saturated, and saturated are fairly unreactive, not more unreactive, fairly unreactive. But if more temperature or if a pressure is given, definitely it will react, or in presence of sunlight also it will react. I mean temperature I told you. Now if chlorine is added to methane, what it will do, you know? How many chlorines we are adding? Cl2. So Cl2. Now what will happen in the sense, from this Cl2, one Cl will move towards this. I mean it will combine with this, and its hydrogen is there, right? That will substitute. I mean chlorine is substituting the hydrogen. Now it will become like this: C, H, H, H. Here instead of hydrogen, one chlorine is moving towards this one, right? So Cl is forming. So we will get CH3Cl, that is this one, CH3Cl. I mean 1 carbon, 3 hydrogens and 1 chlorine, forming one product. And this hydrogen got away, right? It came out. In this chlorines, how many chlorine went towards the methane? Only one. And another 1 chlorine is remaining, and hydrogen is coming towards the chlorine, and it is becoming HCl. That is the concept we have to understand, right? That is substitution. So from this, what we can say, by giving some other element, hydrogen can be substituted. And we have only one equation in examination. You can go with only one equation. That is more than enough. And we have 2 questions. Why is the conversion ethanol to ethanoic acid oxidation reaction? Because ethanol is converting to ethanoic acid by or in presence of potassium permanganate or potassium dichromate, which are oxidizing agents, and oxygen is added to that. And simply to say, here basically here there should be one oxygen, but sorry, hydrogen. This hydrogen got removed here. You can observe there is no hydrogen here, only oxygens are added. So conversion of ethanol to ethanoic acid, we are adding oxygen, so it is oxidation reaction. A mixture of oxygen and ethane is burned for welding. Can you tell why a mixture of ethane and air is not used? So ethane, meth, eth, carbon, carbon, and they told ine. Ine means it is alkyne. Alkane, alkene, alkyne. Alkyne means triple bond and only 2 hydrogens. This is ethane. Here what they told, ethane is mixing with oxygen for case of welding. So welding means you have some idea. If you have 2 rods, and if you want to join these 2 rods, you will go with welding, and there will be welding rod. And they told ethane is combined with only oxygen for sake of welding. Why it will not? Why ethane will not combine with air? This is not happening because when it is combining with oxygen, oxidation reaction is taking place, and combustion, what I told in first concept, hydrocarbon compounds will combine with, if you observe this, hydrocarbon compounds will combine with oxygen to give more amount of heat and light, isn't it? And that ethane will combine with oxygen to give more amount of heat and light. So more amount of heat should be produced to join those iron rods, to weld railway tracks, etc. But ethane, if it is combining with air, what is meant by air? Mixture of different gases. Air means mixture of different gases, where oxygen percentage only less, so that it will not produce that much amount of heat and light. So to get more amount of heat and light, ethane should be combined with only oxygen but not with air. That is the answer we have to give it. And in our next lecture we will see important carbon compounds: ethanol, ethanoic acid. Ethanol means alcohol, ethanoic acid means vinegar, and properties. It will take just 20-30 minutes to explain. After explanation of property, we'll go with soaps and detergents. These both we can cover in one lecture, and we can complete this chapter. So that's it in this lecture.